What are the significant breakthroughs that you see, Deepak, in the semiconductor industry in the next decade? Or, I'm not asking what Intel is working on, but you can tell me what are the things that you see, forthcoming.
Yeah, I don't have a crystal ball to see the future, right? I hope AI gives us a good crystal ball in next decade or two, right? But what I can talk about is the problem areas and the emerging use cases that will drive innovation in the semiconductor industry, right? So, if we talked about the current trends, right? And then if you see in the last 5 years, the connected devices have grown by 4x or so, and in next decade, people are saying that the connected devices may grow to 15x or so, by 15x, in next decade or so. So semiconductors have become part of our life. I call it as our basic needs are roti kapda makan, and now with semiconductors it's like roti kapda makan and chips. That's our basic needs. So
That's right.
yeah, so some of the
I
emerging
mean,
use
the chip,
cases.
I think we're talking about another chip.
No,
The chip that we both are interested in is a little.
And here I'm talking about semiconductor chips.
Yeah.
It's
I
part
mean,
of our life. Such a basic need it is. That's what
yes,
I'm trying
yes,
to say.
yeah. I got it. I mean, you are worried about the real lays and other chips. I am worried about
I was
the
wondering.
SOCs for sure.
Yeah. So some of the use cases, if I were to discuss, right? So the digital twins and the metaverse in the industrial IoT, right? Digital twins where you feed the data from production line or the equipment to your virtual screen and the desk, right? So you are able to predictively predict the failure of the equipment, or do the predictive maintenance of your equipment or the production line, right? So that's digital twin. The metaverse is like you can build the prototype of the next equipment or the next device you want to build physically. You can build it in the virtual world, right? So this kind of use cases and the growth of the connected devices, right? It's generating massive amount of data, and this massive amount of data is like a new oil today. And to handle this new oil, we need better, faster and cheaper chips, basically, right? So in the past, the power, performance, area and the cost has been the driving vector for the semiconductors. That will remain same, and it will continue to be a key vector for driving innovations in the semiconductors, right? So if I were to divide the problems and the emerging use cases driving the innovation in this industry, to simplify, I'll categorize into three pieces, right? The process, the EDA tools and the products, right? So talking about the process, the Moore's law will continue, as Pat Gelsinger says, industry will continue to innovate and evolve Moore's law, implementation of Moore's law, until we are exhausting the periodic table. So that will continue in the next decade, or even beyond the decade, right? The second piece is, as we talked about the heterogeneous architecture and CPU, GPU, accelerators and everything on the same board, right? And that is increasing the complexity of the chip development by 100x, right? So to handle that kind of a complexity and develop those chips faster, right, for with different variants of the chips, we need significant innovations in EDA, right? So EDA will adopt AI and ML techniques at every stage of the chip development flow, whether it's a front end design, it's a verification, testing, debug, so that's where a lot of innovation will happen in the EDA industry.